Hi, I'm Jocelyn Ferguson studying biomedical engineering. I'm one of your hosts and I'm going to be walking you through some of the different engineering facilities that we have here at Purdue University here in West Lafayette, Indiana. I'm standing below the iconic Gateway to the Future arch. This is kind of like the beginning of the engineering mall. A lot of people like to come here and take pictures on tours and when they come to visit. So another one of our popular spots is next to the Neil statue, right outside of the north entrance of the Armstrong building. In the lawn next to the statue, you can follow his moon prints representing his first steps on the lunar surface. Armstrong Hall houses the School of Aeronautics and Astronautics, the School of Materials Engineering, and the first school of engineering education in the country. It also houses the Deans of Engineering Office, the EPICS Community Service Program, and the CARES Hub, an engineering student wellness center. Right now we are in the Kurtz Atrium, which is located in the northwest corner of Armstrong. Hanging above the center of the atrium is a full-size replica of the Apollo 1 command module. This is what would have splashed down in the ocean after Apollo 1's mission to the moon. 2 of the 3 astronauts on board were Purdue alumni. Hanging above the northwest entrance to the building is a 1/3 scale replica of the Boeing X-20 dinosaur, which was being developed in the late 1950s and early 1960s to be the first reusable spacecraft. Finally, around the corner from the atrium near the southwest building entrance, you'll find a wall mural dedicated to Roger Chaffee and a display case with an actual lunar sample brought back by Apollo 17, the commander of which, Gene Cernan, is also a Purdue alum. On prominent display from the Kurtz Atrium is the EPICS Lab. EPICS is a service learning design program in which teams of students partner with local and global community organizations to address human, community, and environmental needs. EPICS was founded at Purdue University in fall 1995 and has become quite popular among engineering students here. Also found in Armstrong are lab spaces for structural dynamics, aerodynamics, control systems, propulsion, and many areas of aeronautical and astronautical engineering. Materials engineering labs and student resource areas can also be found in Armstrong Hall. Right now we're in the Henson Atrium in Forney Hall. This is a very popular study space for students to come and work together. This is also a pretty popular space for student organizations as well as recruiting events. Recent upgrades and additions have seen improvements to lab space and leading-edge technology and high-performance instrumentation and equipment. Labs in Forney Hall are arranged in a hierarchy with basic labs on the first few floors and more advanced labs on the upper floors. 3 of the new classrooms are set up in an amphitheater style with curved tables that make the professor the focal point of the room. Hampton Hall is home to civil and construction engineering. Hampton Hall features a 2-story glass-walled water visualization studio framed by the Loganathan water feature and is designed to showcase high-performance computer simulations of fluid flow produced at Purdue. The room has a tiled wall, a collection of high-resolution LCD screens working as a single screen that allows for the display of water research data. The civil engineering facility and students at Purdue are utilizing the room to visualize water projects. Importantly, the room is always open to the public who can enter the room from above. The room can also be used as a command center for field projects, including deployments of the lab's autonomous underwater vehicle. The Christopher and Susan Burke Hydraulics and Hydrology Laboratory, known affectionately at Purdue as the H2O Lab, encompasses more than 13,000 square feet of research, teaching, and outreach space. The lab's most visible feature is a stunning 3-story water feature. Flowing into the wet classroom, the water feature serves as a reminder of the continuum between research, teaching, and engagement. The AR Rose sensor-based wet classroom is a hybrid lab lecture classroom designed to allow for hands-on engineering education in water subjects and includes a special water feature for their wearer demonstrations, a wet bench, and will ultimately house additional teaching equipment for Purdue's civil engineering water subjects, primarily hydraulics and hydrology courses. The green roof on Hampton Hall is accessible via the second-floor study lounge. It consists of patio study areas surrounded by green plant-covered expanses various soil and plant media, sensors to measure energy flux, and a weather station. Among projects students have investigated using the green roof are heat loads on the roof structure, energy-reducing technologies for the building, and the impact of a rainwater collection system. Mechanical Engineering's Gatewood addition added 41,000 square feet to the building, increasing the size of the building by 55%. It is Purdue's first LEED building, earning a LEED Gold certification. It includes flexible classroom space, student commons, computer labs, student learning labs, faculty offices, conference rooms, and research labs. The clock from the original Hampton Hall, the first mechanical engineering building in 1896, is a highlight of the open atrium. Also located in the Gatewood wing is the Toy Museum. As part of their final project, students from ME 444, Computer-Aided Design, team up to develop a brand new toy, create a working prototype, and present it to a panel of judges at the annual toy fair. Through the years, students have created a wide variety of toy concepts, from a remote-controlled chicken and autonomous octopus to marble mazes and hydraulic cranes. Take a look around, and you might notice metal spacers in the floor along the south wall of the Gatewood atrium that resembles railroad tracks. This is a special nod to the school's historic ties with railroad industry. Railroads used to run right through this area of campus prior to 1953.
Hello, my name is Matthew Shaler. I'm going to be a senior in biomedical engineering this upcoming semester, and I'm from Muncie, Indiana. Today I'm standing in between the Brown Hall of Electrical Engineering and the Material Science and Electrical Engineering building. The School of Electrical and Computer Engineering, or ECE as it's commonly known, is the largest at Purdue with more than 1,500 students. ECE is also the birthplace of the National Society of Black Engineers, NSBE. Brown Hall houses classrooms, lecture halls, and lab facilities for both electrical and computer engineering, as well as one of the largest lecture halls on campus that is used by more than just engineering classes. Recently renovated spaces in Brown Hall are more flexible, with large doors that can open the space to larger class sections, fewer walls, additional windows that give the lab space a more open feel, and more workstations to accommodate more students. The addition of a dirty workspace allows students working on their senior design projects to do the necessary physical construction for their projects on site, while keeping the debris this work creates separate from the rest of the lab.
Hi everyone, my name's Southwick. I am a student here at Purdue. I'm a senior in industrial engineering, originally from Lincolnshire, Illinois. Right now I'm going to give you guys a little tour of our engineering facilities on campus. We're in Dudley and Lambertus Hall right now. It's one of our newest state-of-the-art facilities. It was built in 2023 and serves the needs of many engineering students. It contains lab spaces, classrooms, and office spaces. Dudley Hall is home to the Office of Future Engineers, where families can stop and chat with staff and current students about Purdue engineering. But more on that in a little bit. Many of our Edwardson School of Industrial Engineering labs are located in Lambertus Hall, including our Build at Scale lab, a space designed to pave the way for the future of lights-out manufacturing, where automated systems run with minimal to no human intervention. Our labs integrate advanced technologies to create smart, efficient, and self-sustaining production environments. 10,000 square feet are dedicated to the Build at Scale lab, which features state-of-the-art equipment designed for the preparation of the next workforce. This space is designed to be flexible, modular, and will feature a completely integrated enterprise platform capable of turning raw materials into finished products. A 5-ton overhead bridge crane allows the entire space to be reconfigured to meet a variety of needs and experiments. Our students capture data from individual machines in an automatic storage and retrieval system, or ASRS. Cobots, robots, and drones can assist in operations and be monitored. Data is delivered, modeled, and analyzed in the Idea, Synthesis, and Optimization lab spaces. The Leslie J. Raffel Idea, Synthesis, and Optimization Lab in Dudley 3465 acts as the digital brain of our operations, leveraging real-time data from across the Build at Scale labs downstairs. Our newly launched AI-enabled Robotics Integration Lab gives students hands-on experience working with various robotic systems. The focus is on integrating diverse robots to tackle complex challenges. Students work with the collaborative robot arm and autonomous mobile robots, or AMRs. The Zeiss ScanBox 5120 contributes the ability to accurately measure parts up to 2,000 millimeters in size, using non-contact optical methods, making it ideal for large or complex shaped parts. This lab facility allows space for ergonomic study of the human body. while under various load scenarios, and the study of bodily wear associated with repetitive tasks. The highlight of the lab space is the Move 4D scanning system, which can generate wire-form 4D models immediately. The Bruker Atomic Force Microscopy, or AFM, is a critical tool driving advancements in semiconductor technology and manufacturing. With atomic-level resolution, these instruments enable precise imaging and characterization of micro and nano-sized materials, essential for microchip development. All students at Purdue West Lafayette begin in first-year engineering, where they participate in group work. Students are put into teams and work together on real-world problems. First-year engineering classrooms like these include instructional areas, screens located throughout the classroom, and spaces for group and project work. Also located in Lambertus and Dudley halls are offices for the Women in Engineering program, Minority Engineering program, First-year Engineering Advising, Office of Professional Practice, Undergraduate Research Office, and many other services for engineering students. Nuclear engineering undergraduate and graduate offices and lab spaces are located in Lambertus and Dudley halls as well, while our nuclear reactor research area is underground in another area of campus. The Bechtel Innovation Design Center is a 31,000 square foot state-of-the-art hands-on makerspace for all students. The Bechtel Center and its staff provide students with training, equipment, and guidance to move their ideas from imagination to reality, helping students discover industry-ready skills along the way. It encourages collaboration, allows students to design, build, and test various projects in the indoor spaces and outdoor plaza. The center contains open workspaces, labs, offices, studios, and storage spaces. The Bechtel Center is available to students 24/7 and provides a hands-on environment in design and development for Purdue student innovators. Assets in the center include CNC tools, water jet cutting, laser engraving, 3D plastic and metal printing, composites, paint and surface finishing, welding, woodworking tools, electronics assembly, and other cutting-edge tools. All students can use the facility. The Agriculture and Biological Engineering building is located on the south side of campus and is one of our newer facilities, boasting some incredible lab and maker spaces. In the wet lab, our Biological Engineering and Environmental and Natural Resources Engineering, or ENRE, students learn about bacteriophages, sequencing DNA, and many other tools associated with biological engineering. In our dry lab, students practice skills related to electrical circuits, sensors, controls, robotics, and digital tools for food production and processing. In the powertrain and drivetrain lab, students see practical examples of different types of engines, the components, such as turbochargers, valves, and pistons, involved with each, how these components are designed, and why they are designed the way they are. We have 3 makerspace labs throughout the building focusing on robotics and machine design, including 3D printers and soldering stations. A food process engineering lab with equipment like extruders, mixers, and ovens, and a cellular and biomolecular lab. Moving on to our hydraulics lab. This lab serves to teach applications as varied as construction equipment to robotics. The CNC lab. We have computer numerically controlled lathe and milling machines used to manufacture parts for our design teams, senior projects, or other research projects. Some premier space in this building is our high bays. The first high bay is our environmental space to store equipment used in environmental and natural resources engineering, such as surveying equipment, water monitoring devices, and other outdoor equipment. Next is the agricultural high bay. In this space, we have room to bring in large farm and construction equipment to demonstrate how they work. You can see the ABE building is well equipped for the needs of agricultural and biological engineering students. The 92,000 square foot Martin C. Jischke Hall of Biomedical Engineering was the first of its kind in Indiana. The 4-floor building, strategically located in Purdue's Discovery Park, was designed to provide an innovative environment for interdisciplinary research and teaching. The new 29,500 square foot Innovation Wing, completed in September 2020, provides open concept wet research labs, translational research labs, including a behavioral core, an expanded multidisciplinary student design lab, and support spaces for both instructional and research laboratories. Additional areas of the wing house instructional spaces that support innovative active learning, office spaces, graduate student offices, and interactive team areas. The Innovation Wing uniquely enables the school to increase opportunities for discovery, delivery, and impact. Located in the heart of campus, the Women's Active Learning Center, or WALC for short, serves as a central location for library and study spaces for all students. Open 24 hours a day, 7 days a week, This 170,000 square foot facility houses the Library of Engineering and Science, along with 27 classrooms designed for active learning. Throughout the building, study and collaborative spaces are interspersed with the classrooms, creating highly efficient use of space. The building stands at the footprint of what was once the Purdue power plant built in 1924. Walk, constructed in 2014, includes a museum-like display throughout the building of artifacts from the original power plant, including hatches, steam turbines, and boiler components.